So this example reads, Eva and Jasmine are looking for a new refrigerator for their apartment. Darwin's Appliances is having a one-day 20% off sale on all its appliances. Eva also has a special coupon for 35% off any item at Darwin's. They found a refrigerator at the appliance store for $2,880. If Darwin's honors both discounts during the sale, what percentage of the original selling price will the girls pay for the refrigerator? So of course, since this is a sale price, we're going to use the sale price formula. Again, here's our sale price S. That's going to be equal to the original selling price minus the markdown. So a couple of things to point out. We have a lot going on here. We have a 20% off right here. So there's a markdown of 20% right here. We also have a 35% off. So here's another markdown. And then we have the original price here of $2,880. So what we could do is determine the sale price when we use 20% off. So if we have $2,880, that's the original selling price, minus the 20% off of the $2,880. So I'm just going to go ahead and put in 0.20 times the 2,880. That pretty much reads the first sentence here. So then this, I'm just going to go ahead and plug right into my calculator. 0.20 of the 2,880, that's 20% of the $2,880. So that's $576 off. $2,880 minus $576. So I take the $2,880, subtract the $576. So using just Darwin's 20% off, they'll get the refrigerator for $2,304. Now Eva goes ahead and applies her 35% off coupon. This is what the store gave. If she didn't have a coupon, this is what she would be paying. So now if this is what she would be paying, now she's going to use her coupon, which is 35% off. So now we take $2,304 and I'm going to subtract 35% of the $2,304. So we have 35%, 2,304. So now we have 2,304 minus $806.40. We go ahead and take the 2,304 minus the $806.40. So in the end, they'll pay $1,497.60. And often students will go ahead and do a problem like this because the 20% off is listed first and then the 35% off is listed second. But if we were to rearrange some of these sentences, what if we were to do the 35% first and then the 20% second? Well, let's try that. We have $2,880 minus, and let's just say that we apply Eva's discount first of 35%. So then I'll take 35% of the $2,880. So that's 2,880 minus $1,008. 2,880 minus the 1,008. And that gives us $1,872. Then the store goes ahead and applies its 20% off. So now we'll take 20% of the $1,872. So 20% of 1,872. So we have 1,872 minus $374.40. 1,872 minus 374.40. And there you go. We still have $1,497.60. So what does this mean? Well, it doesn't matter which percentage is applied first because they're both being applied. It doesn't change the outcome because we're taking a certain percentage of one and then applying it to the certain percentage of another. But the question is asking, what percentage of the original selling price will the girls pay for the refrigerator? Well, the selling price of the refrigerator is $2,880. In the end, the girls are going to pay $1,497.60. So what part of $2,880 is the $1,497.60? Well, $1,497.60, and we'll divide that by $2,880. So in our calculator, we'll do $1,497.60 and divide that by the $2,880. And that comes out to be 0.52, or in other words, 52%. Now, as we read these problems, we have to make sure that we read them carefully. The problem says, what percentage of the original selling price will the girls pay for the refrigerator? This problem could have easily said, what percentage of the original selling price will the girls save for the refrigerator? Well, if they paid 52%, then that must mean that they saved 48%. So you have to make sure that as you read these problems, you're reading them carefully. So another way to be able to figure out this 52% without having to do all of this, without having to write all this out, is to make sure that we're understanding what the problem is saying. So for example, they're getting 35% off. They're getting 20% off. So if they're getting 20% off, that must mean that they're paying 80%. And if they're getting another 35% off, that must mean that they're paying 65%. And 80% times 65%, I'm just going to go ahead and put in 0.8 times 0.65. And look at that. That's 0.52. So we could have easily avoided all of this just by making sure that we're reading this properly.